All right, so this is section 6.1, real number, order, and absolute value. I kind of want to start out just showing you some of the definitions. Let me see if I can get this full screen. There we go. Some of the definitions. So they show you what natural numbers are, positive numbers greater than 0, whole numbers include 0. Integers, positive and negative numbers, including 0. Rational numbers. There's a lot involved here. These are all the numbers that can be written as whole numbers, fractions. So whole numbers also can be written as fractions if you put them over 1. These are decimal numbers that have a finite number of decimals, like they have like 3 decimal spots or 4, like it stops. And you also have infinite decimal numbers in here that have a repeating pattern. So all of those fit in the definition of rational numbers. Basically, they can all be put in fraction form. So everything that can be put in fraction form are whole numbers, fractions, decimal numbers that stop and that go on forever but have a repeating pattern. All right, anything else would be irrational. So here, irrational numbers, these are the ones that are not rational. So mainly square root of a number that's not a perfect square, pi, different things like that. And then real numbers, just all numbers are real numbers. So here's a little image breakdown separating numbers in their groups. You have rational and irrational. All of these are under the real number umbrella right here. And then those two groups are separate. They don't overlap. But every rational number, every integer is a rational number. Every whole number is an integer. Every natural number is a whole number. So it starts inside and goes up. It just gets smaller groups. But everything in this box is rational. Everything from the orange and below is integer. Everything from purple and below is natural. But it doesn't translate up. Just because it's a natural number does not mean it's whole. Because at 0 is whole, but it's not natural. And just because it's whole does not mean it's an integer, because this includes negative numbers. These don't. So those are kind of like the groupings. We got several examples. We're going to be looking at comparison of numbers. Are they equal? Less than looks like the L, and then greater than. So we'll be labeling some of those, plotting them on the number line. Notice a double negative, negative times a negative equals positive. They show some of that in the calculator there. And then absolute value. I want you to see these vertical bars mean absolute value. And basically it takes a negative number and converts it positive. It's telling you the distance that a number is from 0. So if a number is positive, it stays positive, and then you remove the absolute value bars. If a number is negative, it converts to positive, and then you remove the absolute value bars. So if you have an expression inside of absolute value bars, you need to simplify it first, then convert it to positive. Like, don't just convert every negative inside of there positive and then do the math. Do the math first, kind of like order operations says parentheses or grouping symbols first, and then do the outside. Let me see if I can. So like this right here, you would want to do 8 minus 2. You don't want to change this 2 to a positive. You do 8 minus 2 first. You have the 6, and then you evaluate the absolute value and get rid of them. It'll be a positive 6, but that negative on the outside makes it negative. And so then we have some tables and some other examples that they show you. But that should be most of what we're going to be talking about here. So we go a little bit into more detail, so spend some time looking at those definitions of numbers and their groupings. And that will allow you to kind of get started here. All right, so we're going to jump over to my math lab now.